Hello, my name is Brad, and I'm one of the engineers at the Canada Masonry Design Center. And today I'm very excited to announce a new version of the MAS software, Masonry Analysis Structural Systems. This is MAS version 4. It was supported by the Canada Masonry Design Center and the Canadian Concrete Masonry Producers Association. And we have a lot of new things to announce, so I'm going to dive right in. The first thing that you will probably notice, even just looking at this welcome screen, is that we have a new multi-story shear wall module. And so I'm going to open up one of those right now. Even before I get into that, I've got one that I'm going to quickly go through. This is not meant to be like an exhaustive, basically tutorial showing you how to use the software. I'm mostly just showing you what's new. So actually, before I get into this demonstration here, I just wanted to say this is not meant to be an exhaustive tutorial going through the whole thing. I really just want to hit on some of the main features. And actually, one of the first things that I want to point out is that if you open the help menu, then what you will actually see is, it's into the screen here. The help files have moved to a new website that we have set up here, basically going through and showing you what's new. You may recall, if you've used MAS, if you've opened the help documentation material before, that this is what you would get basically. You'd go through and we had this compiled document. There were a number of issues with that, mainly just that it was a big pain to format it, or even actually quite expensive to generate the document. And so that's why we switched to having it online. The other thing is just that we wanted to make it more accessible. So now everything that was in that old document is updated and available here. And so you can start search for anything. So even if you start searching like stirrups, for example, you just start typing and it will start populating different results that will come up here. Another thing actually with this website, and it shows up as a result here, is specifically with version 4, anything having to do with the new software. I'm going to run through some of these features, but there are some things basically with existing features that have also been changed. And so if you have any questions about things like that, you can go down and basically it will run through the differences that the things that we've changed or updated, a number of improvements like the way we place bond beams in a wall, some improvements for flanges. Same thing with even just when the way we show shear resistances. We used to just show one value, the minimum value, and now we actually show it course by course. I mean, the MAS software was always checking it at every course, but we were always just showing one line, so now we give you a little bit more information there. Another thing that I just want to point out while we're here is that there are a number of articles that I've written basically going through and trying to explain common questions that I think you may come across when you're going through the software. For example, if you're designing a shear wall and you have earthquake forces, you may notice your factored shear forces being scaled up quite considerably. And so I have basically explanations going through the clauses, basically going through and just explain why are we getting such big amplifications when we're going through and designing these things. So I include CSA references and everything there. So back to the software, you'll see what I have here is a multi-story shear wall. Just looking at it here, you can see I've put the entire thing in as 18 meters tall, but then I have broken it up into 5 stories. So basically you start it the same way you would a regular shear wall. You break up the number of stories. By default, they're all just equal heights, but then what you can do is go into this new floor layout tab, and you see there's an auto checkbox, and that basically means that they just get spread out evenly along the height. Whereas I've changed this first story. You might have a taller podium or like a commercial layer in your building where you might need a different height, and so you can just set that, and then the rest are still adjusted automatically to be evenly spaced. Just trying to save some time there. We do have floor slab thicknesses that are available here too. You can change them all by changing it down here, or if you have different thicknesses for along your height, you can change them individually as well. Going back to this design here, looking at our shear wall, you'll notice that you'll see Group A and Group B listed here. What I've done actually is I've made a second group, so at any point you can click on this Add Group button, and it will create a new set of properties that you can assign to different parts of your wall. There's an Assign Groups tab, so when you click on that, you can choose which parts of your wall are designed. So if you want it, by default, it's all Group A. So when you go through and when you design the whole thing, by default, if you only have Group A, it will basically use the same block, same reinforcement pattern for the entire height of your structure. But sometimes, especially if you're governed by the base of your structure, you may want to change things up along the height. And so that's why we added this feature. The next thing I wanted to show is that we have a seismic tab And so whenever you apply any earthquake loads, I've already populated this table here. We've pre-formatted this, so it's easier to just put in a number of loads fairly quickly. If we draw the loads, you'll see they're all shown there. As soon as you have any seismic loads now, before we would just apply the proper, like the 1.0 factor, and then whatever the importance level was as well. Whereas now we actually have a ductility dropdown if you're using the equivalent static method. For those of you who are using the software from a region where you have very low seismic hazard, then we do have a simplified method. So if you select this bubble, you put in your seismic hazard levels, these spectral accelerations, and then your site data. And then based on what is in the building code, whether or not you're eligible, it will tell you whether or not you can use it. But what I'm going to do is I've already put in my data here for conventional construction. If you wanted to do moderately ductile or ductile, then we have those as options as well. And then if you're checking something that's unreinforced, that is available to you there as well. So once you have this here, I'm not going to go through all these options. Like I said, this is just meant to highlight what's new. We have this here. We've assigned our groups. And so I can click on this design button. And something else to see that's new is that there's basically a progress screen going through and showing as we're designing these things. The process for going through and designing everything in a way that all of the self-weights, axial loads, and everything are always up to date is quite complicated. I do have a full article explaining that, basically how we go through and how we handle things like even calculating drift and deflection. That's another new thing that we added. Same thing with the ductility verification for those higher seismic designs. The software does all of that now, which we're very excited to announce, but it's a very complicated process going through and explaining that. So in this example here, just to show you how we see the results, overall it'll give you a progress here, or basically your overall status, but then here's the breakdown showing you your moment and your shear results based on capacities. If you flag any other errors, like let's say a minimum steel error or something along those lines, then what will happen is that will appear up here as well. And you can look at any of the individual stories by clicking on the tabs, but then also if I zoom in here just by scrolling up, and I can zoom and pan around by holding the right click button. I can look around and it'll show you, you'll see that I have a combination of joint reinforcement and bond beams here in this first story. And then for the other ones, for the group B designs, it's also summarized here, but we have, you see the designs fully grouted, 20 centimeter, 20 MPa block. We have vertical 20 Ms at 1200. So starting at the ends, then working our way in. And so that is how we came up with the design. And in a nutshell, this is the multi-story structure. I did mention deflection, so we do calculate drift as we go on the top here, and we do check that against the drift limits. In general, for multi-story, or just for masonry construction in general, the limits in the building code, like if our importance category is normal, we're looking at 2.5% as an interstory drift. You'll see even at the top where we already have rotation coming in from the stories below, these numbers, typically what I find is that they're not very close. Okay, and when you switch to looking at the interaction diagram, you can see that it's different here as well. There are two different cross sections, and so as you'd expect, there are two different envelope curves that show up as well. The group A for the larger curve, and you can see all the story one designs, all these load combinations are connected here. So you can see some have higher axial loads, and then there are others that have that are more like load combination 15 here that shows up, has a lower axial load and very high lateral loads, and so that's why it's closest to the curve here. And so we show that information as well. We also highlight there's a maximum axial stress level for conventional construction that gets checked now that we have these seismic controls. But basically, this is a summary of the new multi-story module that we have here in Mass. So another thing that we have in these designs, a new feature, is boundary elements. So normally in the software, you're used to seeing something like this. But if you look on each side, it looks like a pilaster, but basically a boundary element can be designed as an area of masonry where you have a tied cage of steel where you can basically get compression steel that's buckled, tied to prevent buckling, so that you can use it in your moment calculations. So you'll notice that the tension force that you normally see in steel, in the boundary element, you see negative values, and so that tells us that the steel is in compression there. And so you'll see at the top of the screen, there's a new boundary element tab in the inputs. So I've already created one. You basically just change it from none to a boundary element. By default, the right one will just match whatever properties you put in the left. And then you can go ahead, you can put any dimension. So if you want to make it longer, or if you wanted to basically just have another section of your wall where you have more steel, you can go ahead and do that as well. So we can change, we can put more more bars, for example, as we check the reinforcement ratios and different things. There's a lot that you can do here, but basically, when you start getting into ductility verifications, sometimes the issue is looking at the layout of your structure or different issues that you have. But in some cases, we can actually achieve higher compressive strains by having this confined area of grouted masonry here. And so there's a lot of research that's gone into that, and it's now in the Canadian the design standard, the S304. And so since it's in a standard, we were able to put that in the software. So like I said, this isn't really a full tutorial on everything having to do with it. However, the software does go ahead and perform these designs for you, including when it goes through and checks it for shear and everything as well. So in any case, if you have any questions, I just want to stress that you can always just contact our office. Mass technical support is available. Basically, if you have any technical questions that come up, you can get either support from myself or another engineer in our office fairly easily. And so we really try to encourage people. Don't spend too much time really banging your head against the wall trying to get it figured out and to get it to work. Please just send over an email, give us a call, send us your file, and we're happy to help you out. Anyways, we're very excited once again about MASS version 4. I hope you are too, and thank you very much for watching this video.